Hey guys, Pankaj here. Welcome back. In today's status video, we are going to talk about another kind of distribution, that is uniform distribution for discrete variable as well as continuous variable. Okay, so let's see what and all I have. Share my desktop. Okay, so under uniform distribution, we have two kind of distribution. One is discrete and one is continuous. So what is discrete? Basically working with discrete and finite values. So we have like 1, 2, 3, right? Between 1 and 2, there is no other value. So that's why it is called discrete values. Okay, and another distribution will be continuous uniform distribution, where let's say you have given values, and within those values, there could be infinite values. Let's say between 1 and 2, right? So 1.1, 1.2, 1.3, and 1.23, 1.45, right? So there could be infinite possible value. That's why it is called continuous uniform distribution. Okay, so let me explain our whiteboard. What are those and how they look like? Okay, so just for repetition, I'm just going to show. We saw one Gaussian normal distribution, right? It was looking like this. It was bell curve, right? Now, if we talk about discrete uniform distribution, okay, so discrete, as I mentioned, it will be like a whole number 0, 1, 2, 3. There's no decimal point here, and so on. And why it is called uniform distribution? Because their probability of getting those number will be equal. No matter what number we have, their probability of getting that, getting probability will be exactly same for whatever number we have. Okay, so this will be distributed across. So let's say the best example to explain about this is, let's say we have one dice. Okay, one fair dice where equal sides are there and all numbers like 1, 2, 3, 4, 5, and 6. Correct. So if I throw a dice, so you may get number called 1. If you throw once again, you may get 2, 3, 4. Basically, one time if you throw, you may get any number, right? Between 1 to 6. Correct. So these are nothing but discrete number. You don't have any number. Let's say in dice there is no phase where you will have number called 1.2, 1.3, 1.4. Correct. You will have direct number called 1, 2, 3, 4, 5, 6. So let's say you are throwing once, and what is the probability of getting number 1? Okay, so we have total 6 number, right? So, and just to get one number, because at time on you can get only one number, right? So either 1, 2, 3, 4, or 5 or 6. So that's why, since we are getting one, total number of outcomes are 6. So 1.6. Now let's say you are throwing again, you may get, let's say you are getting 2, right? So what is the probability of getting 2? Again, this will be 1.6. For 3 also it will be 1.6. For 4 also it will be 1.6, and so on. So if you are going to plot their probability, right, how to look like? So we have 1, we have 2, 3, 4, 5, and 6. And this is nothing but your probability. Okay, y-axis. So your probability is nothing but, as I mentioned, everything will be 1.6, right? So let's say this 1.6 is represented here, right? So probability of getting 1 is nothing but this. And if you plot line here, it will be looking like this. For probability of getting 2 is nothing but same 1.6, correct? Similarly for 3, 1.6. Similarly for 4, 1.6, 5, and 6. You will not see any line between those two numbers. That's why it is represented this. It is kind of stem plot, I would say. Okay, directly a point, and there's a vertical line. You don't see any number here. If you see number, means that is getting converted to continuous, which you'll see after this. Okay, there will not be any number between 2 and 3, 3 and 4, 4 and 5, and 5 and 6. Okay, so that's why this is called discrete uniform distribution. Okay, so those are discrete number, and uniform distribution means getting probability of any number is exactly 1 by 6. Okay, so same probability for any number. That's why it is called discrete uniform distribution. Okay, so we will see this using with the help of Python graph also. Now let me go to another kind of distribution, and that is nothing but your continuous uniform distribution. So there is only thin line difference between this. What is that difference? So let's say you have some number, some numbers are there, right? So their probability of all getting those numbers will also be same. Let's say 1, 2, 3, 4, any kind of number is there, right? And let's say their probability will be what? So you will have some probability, but to get the probability of getting number 1, getting number 2, getting number 3, or 4, or whatever number, right? Between 1 and 2, you will have n number of possible values here. Okay, so there could be so many possible values or probability between 1 and 2. Okay, since probability cannot go more than 0 and 1, right? It will be between 0 to 1. All discrete, all continuous value like 0 0.1, 0 0.2, 0 0.3, 0 0.45 up to 1.0. So minimum value will be 0 and maximum value will be 1.0. So whatever you see here, right, those are nothing but your continuous value. There will be so many possible values or possible probabilities of getting number between 1 and 2. Okay, so that's why you see one line between these. In discrete, we saw only this point and this point, right? But in continuous, there could be so many probability existing between these two numbers. That's why you will see line between 1, 2. Similarly, between 2 and 3, there will be line. Similarly, 3 and 4, 4 and 5. And let's say we have one more number called 6. Okay. So probability will be exactly same. So let's say we have 10 numbers. And this is, let's say, one point is called A, and this is another point called B. Okay. So the divide, if you are going to calculate the probability, this will be B minus A. And here, whatever probability you are going to calculate, let's say you are going to calculate the probability between 1 and 2, correct? So 2 minus 1, that is what you are going to divide total, and area under curve between this line, that is what you need to calculate. Okay, because in case of discrete, we were knowing that this is exactly total number and 1 by 6. This was the probability, correct? But in this case, what is the number here? What is the probability of getting this? So probability of this will be question mark b minus a divided by b minus a. And this question mark we need to find out. How to calculate this question mark? What will be the number here? Okay, that's what we are going to see in the continuous uniform distribution. So any possibility you are going to calculate, it will be area under curve. Okay, so let's take one example here. I'll show you how to calculate this question mark. So let's say one guy is going to office or someone is going to office. Okay, their target is reached exactly at 8 a.m. Okay, but whenever he or she goes to office, there could be a lot of factor where some delay will happen, right? So sometimes that person is reaching exactly, let's say, 4 minutes before, and some person or that person is reaching sometimes, let's say 6 minutes late. Okay, so this will be like before and after it. So some delay is there, right? Okay, so now if you plot a point here between -4 and 6, there could be n number of possible values, right? Sometimes they will be reaching here, sometimes they will be reaching like -2, and before 2 minutes, before 1 minute, and maybe after 3 minutes, after 4 minutes, 5 minutes, like that, correct? So you need to calculate those units. How many units are possible? So how to calculate the unit? B minus A. This we saw here, right? B minus A. So total units are 6 minus 4. So total units are 10. Okay. So you are going to divide number 1 by 10. So basically this height is nothing but, let's say you are going to calculate the height, right? This height will be represented as 1 by 10. Okay. Now if you are going to calculate the probability, let's say we want to see, so we have to develop a formula here. Okay. So let's say I want to know the probability of that person to reach between, let's say here it is 5, and let's say here, let's say it is 2 and it is 5 here. Okay. So what is the probability of that person to reach exactly between 2 and 5 minutes after the 8? Okay. So what is the area under curve here? That you need to calculate. So 5 minus 2, that is total 3 units, right? So you need to multiply. This question mark is nothing but your 3. You are going to put here 3. So 3 divided by 10, or you can say 3 multiply by 1 by 10. This is the probability, exactly 3 by 10. So exactly 3 by 10 is the probability, or you can say 0.3 is the probability of that person who will be reaching exactly between 2 and 5. Okay, that's how you calculate the probability in the continuous uniform distribution. Okay, so let's say I'm asking exactly at 8 o'clock, what is the probability of getting exactly at 8 a.m. exactly at 8 o'clock. Okay. So since we are going to have b minus a, right? So there is no what is a lower bound or upper bound here, right? Exactly at 8 we don't have any unit. So to reach office at 8, probability will be 0, because there is no unit. You need to calculate the number of units here. Okay, so you should have some range. So if there's no range, means probability of that person will be 0. So let's say one example I'll be taking. What is the probability of that person who is reaching before it? What is the probability? Okay, so again you calculate the formula here, question mark, and divide by total number of units. So we have 10, right? So what is this question mark? How many units are there? So 8.
Yeah, so what we were talking whether what is the probability of person who is reaching exactly less than equal to, sorry, less than 8, correct? So 8 is nothing but it is represented in the 0th position, correct? So this is 0. So before 0, how many units are there? 1, 2, 3, 4, right? So exactly multiply p reaching 8 less than 8 equal to 4 multiplied by 1 by 10, because total 10 units are there, right? So probability of getting less than 8 equal to number of units by total number of probable outcomes, total 8. So 4 by 10, or it is 0.4. That is your answer. So basically in the form function, how you can represent that. So let's say function of x, where probability of getting any number which is more than 6, let's say probability of getting more than 6, or probability getting less than -4 will be always 0, because there is no such unit here, right? In this particular portion, if you calculate, if you take a look at the portion, right, we have given the point between -4 to 6, correct? That is your area. Between this only you need to calculate all the possible probabilities. So before -4 and after 6, your probability will be always 0. So what is the probability of getting greater than -4, or probability greater than less than 6, total number of unit? Okay, so in this case we have total number of units 6 minus -4, that will be 10, and whatever number you have, whatever number of units are there, that you multiply here. Okay, so 1 by 10, this is your probability. Okay guys, so that's about continuous uniform distribution. So I'm just going to show discrete uniform distribution with the help of Python, how we can achieve that. So I'm going to import numpy as numpy, np, matplotlib as plt, and scipy stats uniform, and random integer. Okay, so random integer will help you to generate the what is it, discrete uniform. Okay, and uniform will help you to generate the continuous uniform distribution. Okay, so I'm just going to show discrete, because a discrete will have only the line or maybe vertical lines, but in the continuous you'll see a number of possible points, you will see straight line. Okay, so let's go ahead and generate the value here. So let's say I'm generating equal to 1. I'm going to simulate the dice throw, okay, because dice will have exactly 1 to 6, and p is equal to 6. So x I'm going to generate this x number of point I'm going to generate. Okay, so I can generate using np dot one, like 1 to 6. So if you have seen my numpy video, there I showed about a range function, right? So what it will do, it will take minimum, that is nothing but a, and max is b, which will be excluded. So I have to give b plus 1, so that 1 to 6 number I'll get. So I can just show you this. Okay, so now go ahead and generate object for random integer. Okay, so that will be known as what I can say here, discrete uniform, discrete uniform variable, dub, I'll say. Okay, so here I can give rand int, I can give a and b plus 1 because it is going to be excluded. Okay, let's see what is there. It is going to generate one object. From this object, what I'll do, so let me show one thing. So when I talked about Gaussian distribution, right? Your PDF wall, nothing but your bell curve, right? In case of discrete uniform distribution, this is your PDF, these points, okay? And if you calculate the CDF, this will be this plus this. If you add, then there will be some value here, right? That you are going to get. So first value you will be getting here, and second value you will be getting here. Then this plus this you will be getting here, right? So it will be cumulative. That's why you see it is in the increasing order. Okay, so that's what we are going to plot here. So you got DUV. Now, what is my PDF? PDF I can calculate for discrete uniform distribution. How I can calculate from DUV? I can just calculate this function called. Okay, before showing the function, one more thing I want to tell. So whenever you talk about continuous value, right? Continuous values, you will always have PDF. That is nothing but probability density function. Whenever you talk about uniform distribution, instead of PDF, you will be calling probability mass function. Okay, that's the only difference. This is PDF, this is PMF. Why it is PMF called? Because you will not have continuous. This is discrete value. For discrete value, all probability density function will be called as probability mass function. Okay, so that's why under random integers you will be having PMF function. We are going to generate from X, that is 1 to 6. Okay, so let's see what it generates. So how we are getting 1.6? You see, all the probability are same for getting 1.6. This is what we saw, right? Probability of getting this number. It was 1.6. This was 1.6. This was 1.6, and so on. Correct? That's what exactly we saw here. Okay. How to plot them? Let me show. That I'll calculate CDF. Okay. So PLT dot plot. I'm just plotting X, and I'm going to plot the point of PDF, and here marker will be your O, that is nothing but the point. Okay, I can give, let's say, blue color. See here, okay, it's plotting now, and after that I'm going to plot a line here. So this is nothing but a line, oh sorry, V line, vertical line. Okay, and this for each X value, and for Y 0 to PDF. And this, let's say we have B, and I can set little beautification here, 0.2, and here marker size, let's say I'm setting 0.8. So what is the issue here? I think for V line this is not existing, so that's okay. I can set color equal to blue. Okay, I think this is good. Now I can make it, let's say, to. Yeah, so this is the probability we saw here, right? The probability mass function for discrete continuous value, discrete uniform value. Okay, so that was discrete in this case. Okay, so this is about nothing but PDF. So let me just give some title, PLT dot title. This is nothing but ED or PMF mass function for discrete distribution. Yeah, and how to get CDF? You just get this value, add with the next value, again add with the next value. Okay, so how to get CDF? I can make CDF equal to NP dot come sum, that is cumulative sum of this PDF, and that is what is a CDF. How to plot them? Just copy and paste here. So instead of PDF, I'll give CDF, and this is also CDF, and this is nothing but CDF for discrete uniform. Okay. So this is very much clear, right? So that's what about discrete uniform distribution, because all the values will be discrete between certain number, and probability of getting any number will have the same probability. Okay, or basically probability of getting number for any number will be exactly same. Okay, and under continuous probability density, continuous uniform distribution, exactly same kind of graph will be there. Only thing is some lines will be added here. So I'm not going to show that, but you can just see some line here. This line will be added, this line will be added. Okay, and if you want to calculate the probability, basically you need to calculate the area under curve between this. Let's say I want to get uh, what is the probability of getting number between 2 and 3, right? So you need to calculate between this 2 and 3. So how many units are there? Between 1 to 6, total 5 units, right? And between 3 to 1, how many units will be there total? 1. So 1.5. That is the probability. Any number which is, let's say, greater than 2 but less than 5, right? Between 2 and 5, what is the total unit? 3. So it will be 3 by 5. That is your probability in the continuous distribution. Okay. So that's all about this, guys. I hope you understood what is discrete uniform distribution and continuous uniform distribution. Okay, so that's all for today. Thank you so much. See you in the next video. Bye.